Hello, everybody's okay? By the way, I welcome you all to your own channel. My name is Nasir Ibadi. We will have our second lecture on binomial expansions. By the way, try to find a place and pick up the notebook with a pen. Whenever I write the questions, first pause the video, then you have to solve by your own self. If you couldn't, then you can resume the button of the play and watch how can I solve. By the way, today we will have simple questions for the first and second questions, and the remaining question would be tricky. We will start our lesson. I do not want to talk more. By the grace of Almighty God, in the name of Almighty God, we have the first question is x divided by 3 plus 1 divided by x whole to the power 5. Now, what is the expansion of this binomial? We know that if we have x plus y raised to the power, then what is the expansion of this one according to Newton formula? We have n by 0, x to the power n by 1, x to the power n minus 1, y, n by 2, x to the power n minus 2, y raised to the power 2, up to n by n, y raised to the power n. Also, we can write this one like NCR, am I right or not? Or NC0 x to the power n, NC1 x to the power n minus 1 y, and NC2 x to the power n minus 2 y raised to the power 2 up to NCn y raised to the power n. Now, in here, x divided by what? 3 plus 1 divided by x raised to the power 5. This is x, this is y. Now put in one of these formula. They are the same. Okay, and instead of n, we have 5 by 0, x to the power n. It means x divided by 3 raised to the power 5 plus n by 1. N is what? 5, 1, x to the power. Now what is x? X divided by 3. Raised to the power 5 minus 1, 4. And y is increasing. Y is 1 divided by x raised to the power 1 plus 5 by 2, x divided by 3 raised to the power 3, 1 divided by x raised to the power 2, 5 by 3, 5, 3, x divided by 3 raised to the power 2, 5, 4, 3, 2, 1 divided by x raised to the power 3, 5 by 4, x divided by 3 raised to the power 1, 1 divided by x raised to the power 4. You have to expand this expression up to here, up to look to the power. Power is 5, then this should be 5, this one should be 5. Now x divided by 3 is decreasing by 1. It is 0 in here, and every number raised to the power 0, it's 1. Then we can have x divided by 3 raised to the power 0 and 1 divided by x raised to the power 5. Now simplify this one. This is your answer. 5 by 0, it's 1. X raised to the power 5, x to the power 5, 3 raised to the power 5, 243. Plus 5 by 1, it is 5, x raised to the power 4, and 3 raised to the power 4, this is what? This is 81, times 1 divided by x, plus 5 with 2, this is 10. You can simplify n by r. N factorial divided by n minus r factorial times r factorial. Now 5 by 2. This is 5, n minus r, 5 minus 2, this is 3, and 2 factorial. Simplify this one, the answer is 10. Am I right? Yes, this is 10. X raised to the power 3 3 raised to the power 3, 27. 1 raised to the power 2, 1. X raised to the power 2, it is x squared. Plus 5 with 3, this is once again 10. X squared 9 times 1 divided by x cubed. Plus 5 by 4, it's 5. X divided by 3 and 1 divided by x to the power 4. Plus 5 by 5, it's 1. X by 3 raised to the power 0, it's 1. Then 1 times 1, 1. 1 times 1x to the power 4, it is 1x to the power 5. Now in here, x to the power 5 divided by 2, 4, 3, plus in here we can cancel 1x with this one, so we have 5x cubed divided by 81. Am I right? Yes. Now in here, two of them is getting cancelled. We have 10x divided by 27, plus in here we can cancel. Now 10 divided by 9x, plus in here 1 is cancelling, so we have 5 divided by 3x cubed plus 1 divided by x to the power 5. This is your answer for expansion of the question number 1. Write it please. Question number 2. X plus 1 divided by x raised to the power 6. Now this is x, this is y. How you can expand this expression? I think first n by 0, I mean 6 by 0, x to the power 6. Now 6 by 1, am I right? X to the power 5, this one, it's getting decreasing, and this one is increasing. 1 divided by x raised to the power 1, plus 6 by 2, x to the power 4, 1 divided by x raised to the power 2. Like this one, you have x raised to the power 3, 1 divided by x raised to the power 3. 6 by 4, 0, 1, 2, 3, 4, x squared, 1 divided by x raised to the power 4, plus 6 by 4, x raised to the power 1, 1 divided by x raised to the power 5. The last one is 6. 4, this is 5. I'm sorry. So you have this one is 0. Now x to the power 0 is 1. 1 divided by, this is 0. 1 divided by x raised to the power 6. Now simplify this one. What do you have? 6 by 0, it's 1. 1 times x to the power 6, x to the power 6, plus 6 by 1, it's 6, x to the power 5, 1 divided by x, plus 6 by 2. You can simplify here. 6 by 2, 6 factorial, 6 minus 2, 4 factorial, times 2 factorial. You have 6, 5, 4 factorial, in here 4 factorial, and 2, 1. This is cancelled. 2, 3 times 5, it's 15. So we have 15 x to the power 4, 1 divided by x to the power 2, plus 6 by 3, 6 by 3, 6 by 3, it is 6 factorial, 3 factorial times 3 factorial. So you have 6, 5, 4, 3 factorial, 3 factorial, and 3, 2, 1. 5 times 4, it's 20. 20 x to the power 3, 1 divided by x to the power 3, plus 6 by 4, it is once again 15, x squared, 1 divided by x raised to the power 4, plus 6 by 5, it is 6, x, 1 divided by x raised to the power 5. 6 by 6, it's 1, 1 times 1, 1, 1 times 1 divided by x to the power 6, it is 1 divided by x to the power 6. So we don't have like this term, x to the power 6. Now 1 is cancelling, so we have 6x to the power 4, plus 2 is getting cancelled, so we have 15 x to the power 2. Right or not? Yes. In here it's getting cancelled, so we have 20. plus, and 2 is getting cancelled. We have 15 divided by 1 divided by x squared. So 15 divided by x squared plus 1 is getting cancelled. We have 6 divided by x to the power 4 and 1 x to the power 6. This is the correct option. Also, we had something in our lecture, in previous lecture. If we have x plus y raised to the power 2n, x plus 1 divided by x raised to the power 2n. Now, in here we have a term in which that term is without variable. It means that's a constant term, and that term is middle term. The middle term is without variable. It means it's a constant term, and that constant term is 2n cn, or 2n by n. Now find n in here. This is like this one. So we have 2n is 6, n is 3. N is what? 3. Now put that one. 2n is 6 by 3. 6 by 3. 6 by 3 is this one, and that's 20. Am I right or not? So this is the middle term also. And this one is independent of the variable. Maybe that variable is whatever is. So in here 1, 2, 3, 4, 5, 6, 7. We have got 7 terms, and this is the middle term. And this middle term is independent of the what? Independent of the variable. Am I right or not? By usage of this formula, also you can find just middle term. For which cases? For x plus or minus 1 divided by x raised to the power 2n. And this 2n should be a even number. Write it please. Question number 3. 101 raised to the power 4. How you can simplify this one? I'm sure that 101 raised to the power 4 means 101 times 101 times 101 and 101. I think if you multiply these 4 terms, it would be much difficult. Then the easy way is by using of the binomial expression. What do I mean? Can I write 101 raised to the power 4? Can we write this one 100 plus 1 raised to the power 4? Yes, you can. Now if you want to expand this expression 100 to the every power, it's easy. And 1 raised to the power every power, this one is also 1. What do I mean? This is x, this is y. So we have 4 by 0. Am I right? 100 raised to the power 4 plus 4 by 1, 100 raised to the power 3. Now this is decreasing. The second term is increasing. The 1 is raised to the power 1. Then we have 4 by 2, 100 raised to the power 2. If you increase this 1 to every power, that means 1. Then do not write 1. So we have 4 by 3, 100 raised to the power 1. And the last term is 4 by 4, 4 by 4, and this 100 raised to the power 0. Am I right? Now you have 4 by 0, this is 1. 1 times this one, 100 raised to the power 4. So you have how many zeros? This is getting 4th time. 1, second, third, and this is 4th. If you raise 100 to the power 4, so you will have this answer. 4 by 1, it is 4. 100 raised to the power 3, so it is this one. 4 by 2, this is what? 4 by 2. 4 by 2, I think this is 6. 100 raised to the power 2, this is 10,000. And 4 by 3, this is 4 times 100. 4 by 4, this is 1, and 100 to the power 0, that's also 1. So you have what? You have this number plus 4 with this one. So you have this number plus this one and plus 400 plus 1. Now you can add all these terms. 400 this one with this one, it is 401. Now 1 2 3, you have 60 here, and 1 2 3 4 1 2 3 4 5 1 2 3 4 5, this is 40. 1 2 3 4 5 6 7 1 2 3 4 5 6 7, and we have 10. This is the answer for 101 raised to the power 4. 99 raised to the power 5. It's also the same like question number 3. What do I mean? Can I write 99 to the power 5 like 100 minus 1 raised to the power 5? Yes. Now you have x minus y raised to the power 5. Can you expand this expression? Yes. 5 by 0, 100 to the power 5. The sign would be what? Consecutive. What do I mean? One is positive, second is negative. Positive, negative, positive, negative. The first term is positive, the second term is negative. 5 by 1, 100 to the power 4. And this is increasing. 1 raised to the power 1 plus 5 by 2, 100 to the power 3. 1 is increasing. If 1 is raised to every power, then you don't have any difference with the answer. It means do not write 1. Now after positive we have negative. Negative 5 by 3, 100 to the power 2 plus 5 by 4, 0 1 2 3 4, yes, 100 to the power 1, and negative 5 by 5, 100 to the power 0. This is your answer. Now simplify. 5 by 0, it's 1. 1 times this one, so you have 0 0 0 0 2 4 6 8 10 minus 5 by 1, this is 5, 1 0 0 3 4 5 6 7 8 plus 5 by 2, it's 10, 1 2 3 4 5 6 minus 5 by 3, it's once again 10, 1 2 3 4, 5 by 4, it's 5, 100, and 5 by 5, it's 100 to the power 0, it's 1. Now you have simplify. 1 2 3 4 5 6 7 8 9 10 minus 5 with this one, 1 2 3 4 5 6 7 8 plus 10 with this one, 1 2 3 4 5 6 7 minus 10 with this one, 1 2 3 4 5 plus 500 minus 1. Now we can add the positive terms and the negative terms separately, I mean individually. This is this with this one. So you have what? You have 500, 1 2 3 terms, 1 2 3 terms, and you have 10,000, 1 2 3 4 1, and 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8. How many times do we have? 1 2 3 4 5 6 7 8. Yeah, 1 2 3 4 5 6 7 8. We have 100 minus this one with that one. We can add 1. We have 1 2 3 4 5 6 1 2 3 4 5 6 am I right? Yes. Now 1 2 3 4 5 6, then we have 500. Now you can subtract these terms. Now 0 with 1, it's 9. So we have in here 9, we have 4, now this, the fourth term with the fourth term, this is 0 minus 0 is 0, 0 minus 0 is 0. Now this term with this one, this term with this one, 0 minus 1 it's 9. We have in here 9, 9 minus 0 is 9, and we have in here 0, 0, 0 minus 0, this is 0. Now we have 5 and we have 100. 100 minus 5, it is what? 995. I think this is your answer. For what? For 99 raised to the power 5. If I got any mistake, then please, I'm sorry. Write it please. Sorry, in here we have 95. 100 minus 5, this is 95. 95, 0, 99, 00, 499. Yes, this is the correct option. Which one is larger or greater? 1.1 raised to the power 10,000 or 1,000? By the way, how we can simplify? Think first. Which one is larger? 1.1 raised to the power 10,000 and 1,000. It's clear that you cannot multiply 1.1 10,000 times. Why? Because it would be much difficult. Then use binomial theorem. What do I mean? Can I write 1.1 raised to the power 10,000 1 plus 0.1 raised to the power 10,000? Yes, we can write. Now this is x, this is y. X plus y raised to a positive integer. So you have 10,000 by 0, 1 raised to the power 10,000 plus 10,000 by 1. So you can decrease this one by one number, and 1 raised to the power every number, this is 1, and this is getting increased, 0.1 raised to the power 1. Then you have 10,000 by 2, 0.1 raised to the power 2, and you have to increase this term up to where? Up to 10,000 by 10,000, 0.1 raised to the power 10,000. Am I right? Yes. So you would have 10,000 by 0, it's 1, and 1 raised to every power, it's 1. 1 times 1, it's 1, plus 10,000 by 1, it is 10,000, times 0.1 raised to the power 1, it's 0.1, plus some terms. Now you have 1 is getting cancelled, so you have 1 plus 1 times 1,000, it's 1,000, plus some positive term. In here you have sum of what? Sum of positive terms. Now what do you think? 1 plus 1,000, it is 1,001, plus sum of positive terms. If you sum these one with 1,000, you will have the answer greater than 1,001. or smaller than 1001? Greater than 1001. So in here we have something greater than 1001. If you have the answer of what? 1.1 raised to the power 10,000, you have the answer as sum of greater than 1001, then clearly it is larger than 1000. So we can say that 1.1 raised to the power 10,000, it is greater than what? Than 1000. Write it, please. Question number 6. Root 3 plus root 2 raised to the power 4 minus root 3 minus root 4 raised to the power 4. How you can simplify? You have two ways. First, you have to write the expression for this one, and you have to write the expression for this one. Now you have to subtract these two and you will find the answer. Second, use the formula which we gave in the lecture. In the lecture we had, if we have x plus y raised to the power n plus x minus y raised to the power n, we had two formula, for one for the summation and second for the subtraction. For the summation we had what? 2 times of nc0 x to the power n plus nc2 x to the power n minus 2 y square nc4 x to the power n minus 4 y to the power 4 plus some terms. It means in summation you have for this one the even numbers formula, but for the subtraction you had 2 nc1 x to the power n minus 1 y raised to the power 1 plus nc3, the odd numbers, x to the power n minus 3 y raised to the power 3, and nc5 x to the power n minus 5 y raised to the power 5 plus some terms. Am I right or not? Yes. In subtraction you have the odd numbers, but in the summation you have the even number. Now what our question is, it's subtraction, then use the second formula. Am I right? Root 3 plus root 2 raised to the power 4 minus root 3 minus root 2 raised to the power 4. This is x and this one is y. Then use this formula. The second one. We have 2 times of n. What's n? 4. C1 x raised to the power n minus 1. What's x? It's root 3 raised to the power n minus 1. N is 4. 4 minus 1, it's 3 times y. What is y? It's root 2 plus 4 c3 x to the power n minus 1. What is x? Root 3. 4 minus 3, it's 1, and root 2 to the power 3 plus 4 c5. But this is not true for c5. Why? Because for c5 means 4 by 5. In combination, this n should be greater or equal to the r. In combination, we have n is greater or equal to r. So this is not true. It means you have to expand this formula up to 4 by 3. Am I right? Yes. You know this one. By the way, now you can have 2 times 4 by 1. It's 4. 3 to the power 3. It's 27 times root 2 plus 4 by 3. It's 4. Root 3 times 2 raised to the power 3. It's 8. And here 2 times 4, it's 8. 2 times 27, it is 54. Plus 2 times 4, it's 8. root 3 root 8, it is 24. Now 8, can I write 54 like 9 by 6? Yes, 9 times 6, 9 times 6 is 54. Plus 8, can I write this one? 4 times 6, yes. Now you know the root of 9. The root of 9 is 3. 3 times 8, it is 24. Root 6 plus, am I right? Now the root of 4, it's 2. 2 times 8, it's 16. Root 6. Now 24 with 16, it's 40. Root 6. This is the correct answer. Write it, please. Question number 7. Root 2 plus 1 raised to the power 6 plus root 2 minus 1 raised to the power 6. How you can simplify? It's simple. Now, can we use this formula? Yes. Which formula we have to use? Then this is the summation of these two brackets, like this one. So you have to use the first formula. Once again, root 2 plus 1 raised to the power 6 plus root 2 plus 1 raised to the power 6. It's minus, I'm sorry. Then use this formula. 2 times of n. What's n? 6. C 0. X to the power. It is 6 is x is root 2 raised to the power n. N is 6 plus 6 C2 x raised to the power n minus 2. 6 minus 2, it is 4 root 2 to the power 4 times y. What's y? Y is 1 raised to the power 2 plus 6. After 2 we have 4. 6 C4 x is root 2 raised to the power n minus 4. 6 minus 4, it's 2 times y. Y is 1 raised to the power 4 plus 6 C6 x to the power n minus, after 4 we have n minus 1, even number 6. 6 minus 6, x is root 2, 6 minus 6 and 1 raised to the power 6. Finish. You have to increase this formula up to where r approaches n or smaller than n. Then we have 2. 6 by 0. 6 by 0, it is 1, and you can cancel this degree with this one. 2 with 6, it is 3. 2 raised to the power 3 plus 6 by 2. 6 by 2, what this one is? I think it's 15. 6 by 2, 6 factorial. 6 minus 2, 4 factorial times 2 factorial. Now you have 6, 5, 4 factorial divided by 4 factorial times 2 factorial, and 2 factorial is 2, 1. This is getting cancelled. 2, 3, 3 with 5, it's 15. 15. You can cancel this degree with this one. So you will have 2 raised to the power 2. 1 to every power, it's 1. Plus 6 by 4, it's once again 15. And you can cancel this one. It's 2. Plus 6 by 6, it's 1. And this 1 to the power 0. 6 minus 6 is 0. This number raised to the power 0, it's 1. 1 with this one, it's 1. So you have 2 times 2 raised to the power 3, it's 8. 2 raised to the power 2, it's what? 4. 4 times 15, it is 60. Plus 2 times 15, you have 30 plus 1. Now you have 2. 60 with 30, 90. 98. 98 times this one plus this one, 99. And 2 times 99, it is 198. If I had any mistake, then sorry please. You have to know the method. Question number 8. Show that this term is divisible by 64, where n is a positive integer number. How we can solve? It's a simple question. Listen please. Can we write 9 raised to the power n plus 1 like 9 raised to the power n and times 9 raised to the power 1? Yes. Why? Because the bases are same and we can add the powers. Minus 8n minus 9. Can we write this one? 1 plus 8 raised to the power n times 9 minus 8n minus 9. Yes. Now this is a binomial expansion. You have to expand this one up to n power. I mean that it's equal 1 plus 8 raised to the power n. This is x, this is y, x plus y. So you have n by 0, 1 raised to the power n, n by 1. 1 is getting decreased, but 1 to every power it's 1, then I do not write 1. So the next term is increasing, 8 raised to the power 2, n by 2, 8 raised to the power 2, n by 3, 8 raised to the power 3, up to n by n, 8 raised to the power n. And this expansion is for 1 plus 8 raised to the power n. Now if this one is in multiplication with the 9, then this is also must be multiplied with 9. I will write 9 here. Am I right? Yes. Minus 8n minus 9. Now you have 9 times n by 0 is 1, 1 raised to the power n, it's 1, 1 times 1, it's 1, plus n by 1, it's 1, it's n times 8. And you have n by 2, 8 to the power 2, n by 3, 8 to the power 3, up to n by n is 1, 8 to the power n, minus 8n minus 9. Correct? Yes. 9 times with this bracket, 9 times 1 it's 9, plus 9 times here, 9 times this one, 9 times 8 it is 72 times n, plus 9 times with this one, 9, 8 is square, n by 2, plus 9, 8 to the power 3, n by 3, up to 9, 8 to the power n, minus 8n minus 9. This 9 with this 9 is getting cancelled. You have 72n minus 8n, it's 64, n, plus 9, 8 square, n by 2, 9, 8 to the power 3, n by 3, 9, 8 to the power n minus, this 8n is finished. Why? Because 72n minus 8n, it is 64. Can we write this 64, 8 square times n? Yes. Plus 9, 8 square, n by 2, 9, 8 to the power 3, n by 3, plus 9, 8 to the power n. Now what do you think? What do you think? 8 square, and here up to here, it is a factor. So you have to factor 8 square. Now what do you have? You have n plus 9 n by 2 plus 9, 8 square is a factor, so the remaining is 8 to the power 1, n by 3, up to 9, 8 to the power n minus 2. Am I right? This one divided by 8 square, 9, 8 to the power n divided by 8 square. So we have 9 divided by 1 is 9. The bases are same. In division, you have to subtract the power of the numerator from the denominator, n minus 2. Is it correct? Yes. Now, is this one divisible by 64? Yes, this is 64 and this is 64. So the remaining part is n plus 9 n by 2 plus 9 8 n by 3 up to 9 8 n minus 2. What do you think? Is this one a positive integer number? Yes. This is a positive integer number. If something is divided by something else and the answer is a positive integer number, it means that this expression is divisible by the second expression. So we can say or we can show that in reality this expression, if n is a positive integer number, is divisible by 64. One thing you have to know, that n starts in here from 2, not from 0 and 1. Why? Because when 8 got the number of 0 and 1, when they got that numbers, those numbers already cancelled. It means n with the expression of 0 and n with the expression of 1 is already used in this expression. What remains, n starts from 2. So in here you have to put n2. If you put n2, then the answer is a positive integer number. It means that this expression is divisible by 64. I think you have got. For example, if I say 128, is this one divisible by 64? You will say, wait a moment, can I write 127 2 times 64 divided by 64? Yes. So 64 with 64 is cancelled. The answer is 2, and 2 is a positive integer number. If this one is a positive integer number, it means that 128 is divisible by 64. But if you have 130 divided by 64, then the answer is 2 point something. If this one is 2 point something, this is not a positive integer number. If this one is not a positive integer number, it means that 130 is not divisible by 64. I think you have got. Write it, please. Question number 9, the last question for this lecture. Prove that the summation of 3 to the power r times NCR, r starts from 0 up to n, this is equal to 4 to the power n. How you can prove? First, this is the left hand side and this is the right hand side. First, you have to know that what do we have in left hand side? I mean in LHS. In LHS you have summation r starts from 0 up to n, 3 to the power r times NCR. Now it means you have to put instead of r 0, so you will have 3 to the power 0 times, instead of n you have n, combination r starts from 0 and summation means plus. Am I right? Yes. After 0 you have to put 1, 3 to the power 1 times NC1. Then once again it's plus. After 1 you have to put instead of r 2, 3 to the power 2 NC2. You have to use this formula up to where r approaches n. It means 3 to the power n times NCn. Am I right? Yes. Now you have you have what? You have 3 to the power 0, it's 1. 1 times this one, it's nc0, plus this one is nc1 times 3 to the power 1. This one means nc2, 3 to the power 2. After this one, nc3, 3 to the power 3, up to ncn, 3 to the power n, and ncn, it means 1. This is our first equation in LHS. Now, what do we have in RHS? Right hand side, we have 4 to the power n. Can I write 4 to the power n, 1 plus 3 to the power n? Yes. Now this is x plus y raised to the power n. You have to use your formula. X, this is y. You have n c0 x to the power n plus n c1. You have to minus this one. N is decreasing, unity, n minus 1, and the second term is increasing, 3 to the power 1 plus n c2, 1 to every power, it's 1. Then we have 3 to the power 2. I would not write 1 to the power, n c3, 3 to the power 3, n c4, 3 to the power 4, up to n cn, 3 to the power n. Am I right? Yes. Now you have this 4 to the power n. 1 to every power, it's 1. 1 times this one, it's n c0 plus 1 to every power, it's 1. So you have n c1, 3 to the power 1, n c2, 3 to the power 2, n c3, 3 to the power 3, up to n cn, 3 to the power n. This is our second equation. Now compare equation first with second. The first term is nc0, nc0. The second term is nc1, 3 to the power 1, nc1, 3 to the power 1. The third term, nc2, 3 to the power 2, nc2, 3 to the power 2, nc3, 3 to the power 3, nc3, 3 to the power 3. The last term, ncn, 3 to the power n, ncn, 3 to the power n. It means every terms are same. So equation 1 and equation 2 are same. So we proved that this is a general formula for 4 to the power n. Am I right? Write it, please. By the way, it was our second lecture on binomial expression. We will come, inshallah, with the best examples for the third lecture. Allah Hafiz.